Hello, and welcome to Now You're Cooking with Gas. This video is about displaying floating damage with variations for damage type, crit hits, and lucky hits. There are a number of ways of showing floating damage, including using the Niagara particle system, attaching a widget component to the target, or just creating an actor in 3D space with some screen space widget attached. We're going to do that last one, and it's about as easy as it sounds, except that the crit and lucky hit information is generated in the damage calculation, and the damage type is sent along using gameplay tags. To get that information back into blueprints where it's easy to manage, we need to create a custom gameplay effect context. With that, we're going to use another broadcast delegate to send it along. To create a custom gameplay effect context, we need to create the class and also tell Unreal to use it. But to tell Unreal to use it, we also need to subclass ability system globals and then also tell Unreal to use that. So we're going to start by creating the ladder. Ability system globals. Throw the GG on there. I'm going to create this class and wait for Unreal to finish. All right, and then we can create the gameplay effect context. However, gameplay effect context is not a class, it's a struct, so it does not show up in this list. So instead, we're going to use Unreal to generate the files, and then we'll modify it manually. So I'm just going to create ability system globals again. Call this one GG gameplay effect context. And with that done, we'll close the editor. Wait for the red bar to go away. And then click reload. So in the gameplay effect context header, I'm going to replace all of this. So we're subclassing gameplay effect context, and we're adding a bunch of functionality for setting and getting the critical hit and lucky hit information. When you subclass gameplay effect context, you can go in there. You see in the base structure here, there are sections which say subclasses must override this. So get script struct and net serialize. We're also going to include the duplicate to make sure the type is correct, and then the portion right past the class down here. That's what we have here. Get script struct has been overridden to supply the static struct for our structure. Similarly in duplicate, we're using our structure. And then net serialize. If we look at net serialize, you can see that this function it's basically adding a bunch of values to the rep bits, serializing, and doing the opposite, more or less. You don't strictly need to understand this well, But what we're going to do is basically copy this entire function and add our two values to the end of both sections. So that's all we've done here. This looks the same, and then it has the crit hit and the lucky hit added. This value here was 7, needs to be added. 2 needs to be added to it because we added two values. For the ability system globals, we need to override alloc gameplay effect context. This is the function that Unreal will call to create a gameplay effect context. And we're just returning a new GG gameplay effect context. Now, to tell Unreal to use our version of GG ability system globals, we need to add the following lines in default game INI. Gas game here is obviously the name of the project, and this is the name of the class. And I'm just going to compile that to make sure there's no errors. Apparently I had the wrong name typed in here. Next, we're going to create the delegate, which is in attribute set. So much like the 4 params version here, we're going to create a new one, which is 6 params. In this case, we're still sending along the instigator and causer, but also a gameplay tag container, the damage, which is actually the same as effect magnitude here, and the values for isCrit and isLucky. We just need to create a variable down here. And then in the same post gameplay effect execute for InDamage, at the end, anytime damage has been applied, very similarly to the other delegates, broadcast delegates, we're sending along that, that information along with the spec tags, which is the same thing we used to get the tags we use to compare for damage types. We're going to use the data effect spec to get the context handle and then get the context from that. We're casting it to our type. As long as that's valid and it exists, then we're setting these Boolean values to the values that were sent along from the damage calculation, which we'll do next. And of course, we also need to include the header for this class. So to send along the crit hit and lucky hit information, we need to get the context. And of course, cast it to our new class. Context, casted context is valid. We're going to set X is critical hit and set is lucky hit. Now the booleans need to be popped out. And we can use them here. I'm going to come out these two lines so that there's not too much going on. And compile. All right, looks like the broadcast event was done wrong. So what I did is when I copied this in, I used the same attribute event. It should be attribute damage event. All right, with that compiled, we need to add this access in the enemy character. So we're using the same setup as before. We have a change function comboed with the blueprint version. We need to make sure that we subscribe to it. And pass along the information to blueprints. There's the wrong blueprint. In the enemy character, just throw out a new print with the damage. And I'm going to remove the jump code just so it's easier to hit. Also going to go into the third person character, switch this back to Fire Fizz. And you can see the new line. Being called from enemy character. So next we're going to create the widget blueprint. I added 3 icons, lovingly crafted for your amusement. This will be WBP floating text. In here, we're just going to create a canvas with a horizontal, which has an image and text inside it. Both the image and text need to be variables. This will be image floating. Text floating. I'm going to make both these fill. And I'm just going to change the value of the image to 0.2 and the text to 0.8. Let's anchor this to the center. Then I'm going to add an animation. I'm just going to call this float. Add a track to it for the horizontal box of type transform. And we're just taking the Y value, adding the initial keyframe, which doesn't show up. We're dragging it over to 2 seconds, adding a keyframe, and setting that to -200. If we hit play, you can see that the text is just going up. Next, we'll create a blueprint. This is the blueprint we'll be spawning in the world. It's just an actor called BP _ floating text. In this blueprint, we're just going to add a widget component. Set the space to screen, and set the widget class to floating text. And then we can drag that in, call getUserWidgetObject, and use that to cast to WBP floating text. From here, we want to run a sequence. We're going to get the image and call setBrushFromTexture. We use this to create a variable, just call it texture. We'll try to get the text floating, at which point we realize that it was not set as a variable. We use this to set text. Use this to create another variable. And set color and opacity. For this, we can drag that out and make slate color. And then we want to promote this to a variable. Let's call it color. We need to set each of these variables to instance editable and expose on spawn. And then back in the enemy character, we can create a function, show floating damage. It's going to take in a gameplay tag container. The damage text, is crit, and is lucky. That gets called from here. Just sending along all the parameters. And in here, we're going to be spawning an actor. This will be the BP loading text. And you can see that the texture, damage text, and color that we set to expose on spawn are available here. I'm going to split this to send the actor location. Moved up 100. So I'm going to be sending the damage text that we sent into the function. We're going to create variables for texture. It goes way up here for some reason. And color. Now I want to initially set that color to white. Going to add a sequence here. I'm going to split it into a few separate sections. So first I'm going to check if it's a crit. Hold B, click. If it's a crit, we're just setting the color to red. If it's lucky, we're setting the color to yellow. And if it was both lucky and a crit, we could set it to orange. We can then set the texture to the fizz icon I created. Throw another sequence. I like sequence nodes for bits of code that have branches, where you want both branches to just go to the next pin. In this case, we're getting the gameplay tag container, calling has tag. If it is acid, we will set the texture to acid icon. Similarly, if it is fire, we will set it to the fire icon. So if you play the game, you can see that if I shoot him, it does 5 damage. You can see that wonderful physical icon. It's a sword. However, there's no animation because I forgot to add it to the widget. If I hit in the head, you can see that the text color changed to red for a crit. And of course, it's 7.5 because of the multiplied damage. So let's go back into here, go into the graph on the construct node. We want to play animation. And we also want to set the blueprint lifetime. Initial lifespan to 2. So that will, Unreal would just take care of removing it. There we go. So eventually, we might get a lucky hit. There we go. So the lucky hit was double damage and it was yellow. If we shoot in the head, and eventually, there we go. We got a lucky hit that was also a crit, which was orange. To show the acid and fire icons, we can go in here, change this to acid. And that was my acid icon. Change this to fire. And now it's a fire icon. Thanks for watching. If you liked the video and would like to see more, you know what to do. If you have suggestions on future content or abilities you would like to see, let me know down below.